All right, friends. So now it's time for us to dive a little bit deeper into chemistry. And we are going to be working on some new information. We just got finished learning about the periodic table, and now we're going to be moving on to recognizing that chemical formulas are used to identify substances and determine the number of atoms of each element in the chemical formula containing subscripts. This is Texas Science TEKS 8th grade 8.5D chemical formulas. And so before we jump into formulas, we need to understand molecules. So away we go. Some essential questions. What are the basic differences of elements, molecules, and compounds? And what determines the number of molecules in a chemical compound? So we know that atoms are the basic building blocks of an atom, and an element is a substance contained or consisting of a single type of atom. Look on your periodic table, pick one out. There you go. There's an element. And a group of atoms bonded together representing the smallest fundamental unit of a chemical compound is a molecule. That is the book definition. And so in your notes, you need to 100% know and have that a molecule is made up of two or more atoms. That is a very important definition. Molecules are made up of two or more atoms. So these atoms can be the same or different. And here are some molecules. O2, it's a very stable molecule. It's two oxygen atoms. And that number 2 that you see right here, we call that a subscript. I'll talk about that in a minute, but it simply tells you in this example that here's O for oxygen, and there are 2 of them in this molecule. There's ozone molecule, O3, 3 oxygen molecules. And our favorite, our lifeblood, moment of silence while I take a drink of H2O. So refreshing. Anyway, H2O. 2 hydrogen atoms, 1 oxygen. This 2 is not attached to the L. Whenever you're looking at subscripts, you can see that it's down to the right, down to the right. That is the attachment, down to the right. So I can put an O here, but that 2 is attached to the hydrogen, not the oxygen. And then lastly, CO2. This also is a molecule. Why? Because it fits the definition of 2 or more atoms. 1 carbon, 2 oxygen. This is carbon dioxide. And then we have this interesting one, H2SO4, sulfuric acid, 2 hydrogen, 1 sulfur, and 4 oxygen. A very important thing to note is, there's a bell, that if there is no number present, as you see here, it's always assumed 1. See, no number here, 1 carbon, no number here, 1 oxygen. Hopefully you can understand that moving forward. So let's take a look at this example of hydrogen. Or oxygen, I'm sorry, formed when 2 or more atoms bond chemically together. Elements can bond with the same atoms or different atoms. These bonds form as a result of the sharing or exchange of valence electrons. Now you're understanding, now it's starting to make sense what those valence electrons are for. We knew that valence electrons were synonymous with reactivity, right? We know that when you see valence electrons, you know that you are looking for reactivity. especially in a question. If a question is talking about valence electrons, be looking for the word reactivity in the answer choices. Anyway, let's check this out. We have oxygen here. We have 6 valence electrons. It's in group 6, right? 1, 2, 3, 4, 5, 6 electrons in its outer shell. So over on this side, we also have 6 valence electrons in the outer shell. We know that group 6, they are nonmetals and they like to gain electrons to form negative ions, right? So look at how well these pair. They end up sharing some of their valence electrons, and now count them. They come together, they form this molecule, and now count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Because they're sharing these valence electrons, now it's a very stable molecule, when previously by themselves they weren't as stable. And we know that stable means a full valence shell. They want to become a full valence shell, so they will readily react with other elements to do so. 2 oxygen atoms here are bonding by sharing electrons. All right, moving on. So our favorite, one of our favorites, NaCl, we know that by themselves they'll kill us dead. You take some Na, deader than a doornail. You drink down some chlorine, deader than 2 doornails. We have explosive solid and poisonous gas, but you mix them together and they're amazing on roasted broccoli with a little bit of coconut oil, and you sprinkle some explosive solid and poisonous gas that is combined on it, and it's amazing. So but you see, it should make sense to you that by putting these elements into our bodies can only take so much. Even if it has compounded into a safer substance, which is sodium, NaCl, we still can't have too much of it. It will cause problems in our body. That's why, you can't be having foods and eating foods so rich in sodium. Too much of that is a problem. That's why you should be reading the back of these boxes of these processed foods that are in your cupboard, because they happen to be rich in NaCl. Some of those frozen meals that you're eating, look on the back of it and check out how much sodium they have, because too much is too much. But so we now know that a molecule is 2 or more atoms, but a compound is 2 or more elements. And you got to understand the difference between a molecule and a compound. So let's do a quick test. We have O2. Is that a molecule or compound? That is a molecule. NaCl, but let's go back to that O2. Why is it a molecule? Because it's 2 or more atoms. Now we have NaCl. Is it a molecule or a compound? Well, you're going to say it's a compound, but guess what? It's also a molecule. So the rule of thumb is not all molecules are compounds, O2 for example, but all compounds are molecules. 2 or more elements makes a compound. Each element is an atom. So 2 or more elements also means 2 or more atoms. That's why all compounds are elements. But no, all compounds are molecules, but not all molecules are compounds. So you need to understand the difference. So here we go. We're looking at our friend H2O, And these chemical bonds are a result of the sharing or exchanging of electrons among the atoms. The smallest unbreakable unit of a compound is called a molecule. So in this case, you have two hydrogen atoms, each of them with one valence electron. Remember, group 1 loves to give away their valence electrons and become positive ions. So oxygen needs 2, and there's 2 hydrogen atoms, each with 1 that would love to share, and so they do. That's why water is so very stable. And you can see in this water molecule here, we have 2 H's and O's, and look at how they're sharing so well. We know that hydrogen atoms, they have 1 orbital, and we know how many electrons can fit in that outer shell in the first row. That's 2. So hydrogen, very stable here. Oxygen, you count them up, 1, 2, 3, 4, 5, 6, 7, 8, very stable. Another quick break so I could drink some H2O, but very, very stable after they react. This here is not only a compound, 2 or more elements, it's also a molecule because it's 2 or qualifies as 2 or more atoms. 2 hydrogen, 1 oxygen. And this is just another graphical representation. Elements are what they are, either all on the periodic table. Molecule is going to be 2 or more elements here. Not all molecules are compounds, but in this diagram you can see that all molecules qualify as compounds. That's why this circle is inside the molecule. Just another way to look at it. I'm going to pause it on I'm not going to pause it on this screen. You can take an opportunity and see if you can get all these questions right. And remember some of the rules, that if you get a check mark in the compound, you must also have a check mark in the molecule. And you must also have a check mark in both compound and molecule. So, with that, I'm going to move on through so you guys can see what the answers are. So we have O2 is a molecule and an element, and then go down to the bottom one here. H, it's a single H. It's just an element. Does not qualify as a molecule, does not qualify as a compound or. But look at CH4. It's a molecule, it's a compound, and both molecule and compound. But it does not qualify as an element because it's 2 elements. Element, singular, not plural. Just make sure you're paying attention. Compound, we already know, is more than 1 element. So it could be a long string of elements here, and it will qualify as compound, molecule, and both compound and molecule. So let's talk a little bit about chemical formulas. A chemical formula is a recipe for a chemical substance. It tells the number of atoms of each element in a compound or molecule. That's all a chemical formula gives you. It doesn't tell you what it looks like. It doesn't give you any other descriptions. It simply is a recipe. This is very testable. So understand that all the information that a chemical formula gives you is it tells you the number of atoms of each element in a compound or molecule. That's what a chemical formula does. It uses symbols for the elements present and subscripts to indicate the number of elements. So in this case H2O. 2 hydrogen atoms, 1 oxygen atom. So let's move on to a different one. Let's try, I'm going to throw out another definition. So a subscript is attached bottom to the right of the element. It tells you how many atoms of that element there are. How many atoms of that single element that it is attached to is. Remember, if it's in the middle, it is only attached to the number on its left. This is the attachment here, H2, O2. It's never on the other side. It's only attached to in this format. So we do have something else called a coefficient. And it's the number in front of the element symbol, right? Which indicates the number of molecules there are there. And now maybe it sounds a little confusing at this point. Take a deep breath, no big deal. So let's back up. A chemical equation is a shorthand that scientists use to describe a chemical reaction. It's really scientists' way of explaining it. This is what's happening. And so they've come up with different ways to help it make sense. They came up with subscripts and they came up with coefficients. So, and also, as I said earlier, if there's no number there, it's always assumed 1. So if no coefficient appears in front of a molecule, we interpret it as meaning 1. So let's look at this reaction. We have our reactants on this side, 2 H2s plus O2, and then something happens here to make it react. We call it a yield. So these elements, these molecules will react and form this compound, 2 H2Os. So you can now you can start counting it. The coefficient gets distributed to all of the elements in its formula that is attached to it. So this 2 gets distributed to the H, and it also gets distributed to the O. And I'm sure you've probably heard a teacher over the years say something like, and I'm going to get this wrong, but hippity-hoppity, distribute this property, or flippity-floppity, distribute the property, whatever. But the 2 goes to the H, the 2 goes to the O. So 2 times 2 would be 4 hydrogen here, and 2 times 1 oxygen is 1 oxygen here. Sorry, 2 times 1 is 2. And you can see it here, the 2 blues is the oxygen, the 4 H's are the hydrogen. So here are some practice equations that you can do, where you can just kind of, and I'll do this first one with you. Let's do it. So we have CH4 plus 2O2 yielding CO2 plus 2H2O. So right now, what they really want you to do is, let's just count the molecules. And you do that by looking at the coefficient. There's no coefficient here. How many CH4s do you see? 1. How many O2s do you see? The coach, or the coefficient, tells us 2. We have 1 here, and we have 2 here. Super simple, y'all. Go ahead and figure out the rest of these. Make sure you can identify that. Boom. There's your answers. So that was it. We're going to do some more practice as far as this is concerned. We're definitely going to be looking at different molecules and compounds and counting atoms and establishing how many elements are present and all of that. You guys are going to become amazing at this before our next unit test. But that's it for now. We will talk to y'all soon.